So this whole unit is based around the ideas that come from how do we change the stuff that we know about triangles and relate them to circles. Now the idea is if we would draw a circle with a radius of 1, which you see in this picture here, and we go all the way around, there's a definition for this circle. It's called the unit circle. And it's called the unit circle because the radius is 1 unit. Now any point that's on this circle, like this point P here, can be found by the relationship between the x-coordinate and the y-coordinate. And because of Pythagorean theorem, you know that a squared plus b squared equals c squared. So using x and y here, we would know that x squared plus y squared equals 1 squared. That's just the Pythagorean theorem. And in fact, that is how you would find the equation of any circle. So the equation of this particular circle is x squared plus y squared equals 1. Just for fun, I'll show you how you do any circle. Let's say you wanted to find out, if I pick the point 2, 3 and pick a radius of 4 and drew a circle. That's what it would look like. If I could draw better, it would look even better. And it would use the equation for all of these points to find any point on the end of this circle. And if you look for a pattern, you could probably now take that idea and do any circle anywhere and find the equation for it. So if the center is at 2, 3, then you'd have x minus 2 squared plus y minus 3 squared. Just transformations, moving it to the right 2 and moving it up 3, equals 4 squared because the radius is 4. But we don't have to do circles other than the unit circle. The unit circle is the one that we're going to be dealing with and looking at things that happen with the unit circle. So the first thing is, that's the equation of the unit circle. That finds any point anywhere on the circle. If x squared plus y squared equals 1, then you know that point is on the edge of the circle. Turning your page over here, what we're going to do with this unit circle, again, we're going to draw and make a triangle here. A right angle triangle.
Sorry for the interruption. If we could please have the following two individuals with the license plate, FKZ500, and the other license plate is HAD683. If you could please come to the office for a message. Thank you.
So if sine theta is the opposite over hypotenuse, that's something we know about triangles. And if we look at the triangle that we made, the opposite side length is 1, the opposite side's length is y, and the hypotenuse is 1. So we get that sine theta is the same as the y coordinate. If we look at cos, we know that cos of theta is the adjacent side over the hypotenuse. And that gives us that cos of any angle theta is the same as the x-coordinate on the unit circle. And tan being opposite over adjacent, gives us that tan of an angle is just y divided by x. So we can now rename things any point on the unit circle, so if I would pick, some point down here, normally it would have an x coordinate and a y coordinate. Okay? If I wanted to find out what that x coordinate and y coordinate, I'm just picked a random angle. Just sometimes it's easier to see if we actually put numbers to this. So with that, that looks like 180. It's less than 270. Let's call it 260 degrees. So if I have 260 degrees, I can now find out what x and y are, because any point that are on the unit circle will always have cos of theta as the x coordinate and sine of theta as the y coordinate. So if I go to my calculator and I type cos of 260 degrees, because it's in quadrant 3, my calculator knows it should give me a negative answer, and it gives me negative 1.73. And if I go sine of 260, because it's in quadrant 3, my calculator gives me a negative answer again, which makes sense. And some things to sort of recognize about those answers, just sort of mental math stuff that you'll do with the unit circle. Since we're dealing with a unit circle and the radius is 1, you will know these 4 points right away. If the radius is 1, I go over 1, but not up anything. That point would be 1, 0. This point up here, the x coordinate would be 0 and the y coordinate would be 1. Over here, my x coordinate would be negative 1 and my y coordinate would be 0. And down here, my x coordinate would be 0 and negative 1. When I look at 260 degrees, does it make sense that my y coordinate is very close to negative 1? I got negative 0.984. Estimate-wise, that looks like that's quite accurate. If I look at my x coordinate, negative 0.2-ish, looks about accurate for where 260 degrees would be. So that gives an idea. Now this is a very, very important concept. We're going to write down sort of the 3 big ideas that this unit makes at the bottom of our page, and we can now say them because of what we see here. So at the bottom of your page, you have space, and what we're going to write three big ideas from the unit circle. The first one, which we just saw, any point on the unit circle has the coordinates cos of theta, comma sine of theta. So what we're going, if we know one thing, if we just know the angle, then we're going to know the coordinates of that point, which is a very powerful thing. The second thing is we take the equation of the circle, okay? And you know the equation of the circle is x squared plus y squared equals 1. But now, since x, if we go back to our circle, since our point x comma y, now we can replace x with cos, and we can replace y with sine. And because the equation of the circle is x squared plus y squared equals 1, we now can rewrite that as cos squared. And the interesting thing about writing sine squared and cos squared is you write the squared in between the angle and sine, or in between the angle and cos. You don't put it at the end because that would refer to just the angle being squared and not the whole thing being squared. So this cos squared is the same thing as writing it in brackets and writing squared, but mathematicians don't like to write brackets. So in order to differentiate between just squaring the angle and squaring the whole thing, they put the squared in between the cos and the theta. Cos squared plus sine squared equals 1, and you'll more often see it written with sine first. It doesn't matter, but that's the same as sine squared plus cos squared equals 1. So now you can do some very powerful mental math. Okay? In your head, what is the sine of 13 degrees? Okay, you got it? Square it. You got the answer? Now in your head, do cos of 13 degrees. Now square that. Add the two together. What do you get? 1. Okay, no, you didn't actually have those numbers in your head. I was looking around. Some people were like, are people actually figuring this out? No. Sine of 13 degrees, you can't figure that out in your head, and you're not going to be expected to. But it is true, if you type it into your calculator, that sine of 13 degrees squared plus cos of 13 degrees squared will equal 1. And that'll work for any angle you choose, even if it's 15,000. Sine of 15,000 degrees squared plus cos of 15,000 degrees squared. Add them up, you will get 1. So it's a big idea because it's always, always true. Yes? Yeah, on your calculator you wouldn't need the brackets because it won't allow you to type the squared in between. So when we go bracket cos of 13 bracket squared. Oh, it added an extra bracket, so I got to close that bracket. Got to try harder. Bracket squared plus excuse me, bracket sine of 13 bracket bracket. You do because they added the one bracket automatically when I type sine. So the first bracket that I close closes that little set, and then I need another one to close that. It would just square the 13. So this gets, it's equal to 1. Cos of 13 is 0.97437000648. Squaring that, if you were doing the mental math as we went along and you wanted to check if you were on the right track, that's where you should have been. But chances are, yeah. If you did have those numbers correctly to that many decimal places, come see me at lunch. I can probably get you hired somewhere. Okay. That is the second big idea. Then the third big idea from this unit circle that we can now say is that since tan on the unit circle would be the opposite over adjacent, and the opposite is y and the adjacent is x, but y we noticed was always sine and x was always cos, we now know that tan is equal to sine over cos. And that's also true for any angle. Okay? Let's pick another random angle. Let's make a fraction here. Let's do sine. Today's the 23rd. Sine of 23 divided by cos of 23 comes out to 0.4244. If I would do tan of 23, it's exactly the same answer. And this is also always true, doesn't matter what angle you pick. So these are three big ideas that we get from just making some observations about our unit circle.